Hi, hello friends. Welcome to the today's session. Welcome to Unacademy and welcome to Srinivas Sir classes. Today we are going to discuss the very important concept framing methodologies, especially in data linking. So, what is a frame and why there is a requirement of construction of frames? And what is the header size of the frame? And what is the trailer size of the frame? We are going to discuss in this session. So, my dear friends, before entering into the session, let us say our anthem that crack GATE and DSE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. So Unacademy has created a virtual platform, dedicated online platform between dedicated students and dedicated faculties. My dear friends, myself is Srinivas Rao IS, having more than 15 years of experience in the GATE with various subjects. I also had industry experience as a data admin and a system analyst. Also had certifications in database side, networking side, and Red Hat Linux operating system side. My dear friends, I taught in many premium GATE academies with a high success rate. Many of my students became post-graduation in premium institutions. They became alumni of IITs and IITs and central universities. You also can achieve such kind of positions just by clearing a prestigious competitive examination called GATE. So to qualify prestigious competitive examination like a GATE, you're supposed to have a proper training and a proper guidance and a proper parenting that is given by Unacademy. On behalf of Unacademy, I am assuring that you can able to achieve all your dreams. Your dream is our dream, and our dream is Unacademy's dream. So, my dear friends, what you all need to do to achieve the success, just to take the admission from Unacademy. Use my referral code to get the maximized discount. And there are two kinds of subscriptions. So one can be obtained by current fourth year students. So and the other kind of subscription is a 24-month subscription, and that is can be taken by current fourth year students and second year and third year, even fourth year students, first year students also can able to opt. So once you get the admission, then you are going to be called a premium member or a plus student. So my dear friends, Unacademy also offering iconic batch 1:1 faculty guidance. So you can also attempt that. So once you became a member of Plus, then you are going to get a top quality teaching, live sessions, like quizzes, mock test, and mock sessions. So they are all useful. They are all useful, and they are also going to provide some kind of tips in the lectures, which are very beneficial by reducing your rank. That's why, my dear friends, so do become alumni of IIT, NIT, Central Universities, or Triple IITs. Please join Unacademy immediately. Let's Crack Gate CSC is our YouTube channel. Subscribe our YouTube channel. Use my referral code to get the maximized discount and hit the bell icon for the latest notifications and updates. So, my dear friends, we will see what is the concept of a frame. So, whenever you talk about the data link layer, the data link layer has got two different sublayers. Data link layer got two different sublayer. One is a logical link control, the other one medium access control. Both are having a common principles except two. We will see that what are the non-common principles and what are the common principles in the series of computer network classes which are offering by Unacademy in a prestigious manner. So what is a frame? A frame is nothing but a group of bits. Whenever network layer, this is sender side I am saying, whenever network layer passes the data to the logical link control, which is a part of your data link layer, first sublayer is of your data link layer is LLC. So whenever you send a data from network layer and that packet is received by LLC and it is going to add its own headers. it is going to add headers. And the data link layer, especially, it also attach a trailer in order to detect errors and correct errors. So my dear friends, whenever a network layer transmits some kind of a payload, then data link layer is going to add headers and trailers. That means a frame is nothing but which is encapsulated. The packet is encapsulated form at the data link layer is called as a frame. So what are the functionalities of logical link control? Because as we are learning a first sublayer that is called LLC, which is of your data link layer. So it is a link to link communication. First one is a link to link communication, and it is trying to use the concept of a framing because data link layer protocol data unit is a frame only. It also provides error detection, correction, flow control, error control. Apart from that, virtual communication and remote transmission of raw transmission errors. So it is also going to provide a virtual communication, also called as a logical communication, and which is try to see that the raw transmission errors can be removed, which are provided by your physical layer at the receiver side. So today our agenda is nothing but framing only. So my dear friends, what is the meaning of a frame? A frame is nothing but a sequence of characters. Whatever a network layer sends the data in the form of a packet, which is being called as a frame, just by taking that payload, adding the headers and the trailers, we are going to call it as a frame. Whenever receiver side, if you send the frame at the data link layer, then it is going to send the remaining data to the packet just by unencapsulate. That means what? We are trying to unwrapping of your data, and the packet is being pulled from your frame. So this payload we are going to call as a packet, especially whenever you talk the internet layer. And this is whatever internet layer is sending this data is called as a payload. To that we are going to add additions, that is headers and trailers. So this is a frame. And why there is a requirement of frame? That's very important. Why there is a requirement of frame, my dear friends? So whenever you call that, a frame is one of the PDU of your data link layer. So data link layer cannot able to understand anything except your frame concept. That's why your data which is coming from your upper layer is being attached in the form of frame, because the data link layer can able to understand only frame only. A frame is nothing but set of characters. And what is the frame format? A general format I am speaking according to Ethernet. A frame is got a data and a frame has got a header. The header consists of your start of the frame and a MAC address, source address and destination address and a length and a frame check sequence, which is nothing but error detection codes and end of the frame. So this is your start of the frame and this is your end of the frame. And your data, whatever you are transmitting from internet layer, observe that this is being considered as your data. I am calling it as, according to the previous slide, it is called as a payload. So my dear friends, this is what is the meaning of frame format. Now let us see how to construct the frames. So frame construction methods are, how are you going to construct the frames? There are two varieties of frame construction methods. One is a fixed length, the other one variable length. Both are running in nowadays. Fixed length is also going on, variable length is also going on. Both are available. So what is the meaning of fixed length? The size of the frame is a fixed. So even you send any number of group of characters, I am going to send the data to the other party in the form of fixed length only. As the frame size is a fixed, it is a very easy to the receiver to identify boundary of the frame. A simple and easy technique, fixed length. For example, is your Ethernet is following a fixed length frame. So therefore, my dear friends, so all the frames are same sizes. Once you define the frame size, then it is not going to be changed during data transmission. It is a fixed. So Ethernet, whenever I am talking, why I said that fixed length is Ethernet is an example, because Ethernet minimum you need to carry forward 64 bits, and maximum it can able to support only 1518 bits bytes only. So more than that, it cannot able to transmit. You have to cut and transmit the data. So minimum is this much and maximum is this much, which is inclusive of your 18 bytes overhead. That is a 14 bytes header and 4 bytes trailer. So what is the benefit? The boundary of the frame can be easily identified by the receiver, because I know the length of the frame. According to that I will cut, and the rest is going to be considered as the next frame only. For example, a frame capacity is 1000. Frame capacity is 1000, but sender is sending 2000 bytes of data. Then immediately I am trying to construct your frames into two parts. So one is F1, which is of 1000, and the other one is F2, which is of another 1000. What is the problem here? Yes, there is a big problem. What is that? You need to maintain a separate field apart from your data called payload. So apart from your data called, what I mean to say, we need to add extra stuffing. Why extra stuffing? Because you see that the sender is sending in 900 bytes of data, but your fixed size frame is about 1000 bytes. Therefore, what is required, my dear friends? There is a requirement of extra field you need to maintain, that is called padding. So you need to maintain extra field called padding along with your data frame. Advantage is the frame boundary is easier, but disadvantage is that so you need to maintain a what? Padding concept. Why padding? I will show you. Observe now. For example, sender sends as usually 900 bytes of data, which is coming from your internet layer. And this data, whenever it comes, I said that your frame size is the 1000 bytes. Therefore, if you send only 900 bytes of data frame, then receiver unable to understand the boundary of the frame, then you require, what do you require? You need to see that what is your data. You need to see that my data is only 900 bytes, and the rest you say that 100 bytes are supposed to do dummy characters, because I need to fulfill your full length frame, because this is a completely capacity of your 1000 bytes only. So you need to have extra characters, that is called padding, because you need to see that the length of the frame is supposed to be 1000 bytes. If the length is not 1000 bytes, it is a very big problem at the receiver side. He cannot able to detect the boundary of the frame. That's why sender has to do this kind of a framing mechanism just by adding extra stuffed characters. Extra data means fragmentation we do. We already seen this example. Whenever you are sending a 2000 bytes of data, I am trying to do fragmentation, splitting and transmit the data, because each data capacity is only 1000 bytes, not more than that. And whenever you are sending a lesser, then you need to do a concept of what? Padding. This padding also is required in your Ethernet. So apart from that, you want to avoid the padding concept, there is a requirement of what? Variable length. So variable length is nothing but frame to frame you can able to maintain multiple sizes. The size of the frame is not fixed. We are not going to fix the size of the frame. It is random. As much you want, you can able to decide. That's why the frames can be any size. But there is a big problem. When I say that a frame consists of 50 characters, other frame consists 100 characters, other frame consists 200 characters. How are you going to enable the receiver that this is the boundary of the frame? It's very difficult at the receiver side to identify the boundary of the frame, because the frame consists of some random size of data. That's why, my dear friends, there is a requirement of proper mechanisms to construct the frames. Whenever you are using the concept of overlength, variable length framing, because we want to avoid the concept of padding. So frame 1 can have 100 bytes and other frame can have any length of data. It's not fixed at all. The advantage is that there is no concept of padding, but disadvantage is that sender must be very cautious while transmitting the data. You need to see that the boundary of the frames are to be visible to the receiver. Therefore, receiver can able to cut and short the frames to the internet layer. So disadvantage is that. So we must say start as well as end of the frame. This is very important. When you say the end of the frame by the sender, then receiver knows that okay, this is my end of the frame, and the rest I can consider that next start of the frame. And advantage is that this is the proper advantage. No padding is required. I will show you one example. What is the major problem with the padding? I say length of the frame. Length is equal to something like 1000 bytes. And the data is coming from upper layer. Data coming from upper layer is 1010 bytes. Now you tell me very big problem in this example if I am following a scenario called fixed length. Because the length of the frame is a fixed, I said that length of the frame is 1000. So therefore your 1010 data is being split into two fragments. One is called 1000 bytes. This is the frame 1, and the other one is called another frame that is called as 10 bytes, which is of frame 2. Now you observe, my dear friends, here how much is the padding I am doing? The padding is 0 bytes, because exactly I fit the particular data size into a frame. But here I am sort of 990 bytes, because your length of the frame is 1000 bytes. Therefore, you need to pad unnecessarily 990 bytes. Therefore, my dear friends, here what is your overhead? Exactly, there is a overhead. How much is the overhead? 990 bytes are your overhead. So your efficiency, if you consider here, what is your efficiency? Out of 2000 bytes of data I am sending, please understand, out of 2000 bytes of data, my useful data is only 1010 only. Therefore, your efficiency is a useful divided by total. Useful is a 1010 bytes, and the total you are sending is a 2000 bytes. This is a big problem, especially when you are having a limited bandwidth concept. So whenever you are having a limited bandwidth capacity, my dear friends, this is how it's handled. So there is a big overhead and there is a less efficiency whenever you are increasing the padding. So what is the relationship? If a padding is increased, we know that overhead is increased, and we know that link efficiency is going to be reduced. Finally, your throughput is also going to be a lot of comparison between your bandwidth and throughput. Now, our task is that we want to show end of the frame to the receiver. How are you going to show the end of the frame to the receiver? We are having a different techniques. One technique is called as a length field. So using a length field, we can able to decide that how much data you are going to. So we can insert a field called a length in every frame, which tells that the length of the frame is this much and length of the frame is this much. Therefore, receiver can able to easily identify the boundary of the frame by seeing the length of the frame. So what is the real-time example? The real-time example I will show you, my dear friends. Observe. This is sender side. Whenever I say sender, you please see that data link layer only I am talking. So sender sends a frame, and the sender is also sending another frame. Why I am dividing into smaller? Please observe carefully. Now I say, please understand carefully. This is, I am maintaining a length field here, I say length is 10 bytes. This is for frame 1. And I say length is a frame 2. In this, length may not be the same because we are using the concept of what? Variable length. So I can say that 100 characters. So whenever you send these two frames together to the receiver, what is going to happen? Receiver can identify boundary of the frames easily. You also are witness. Why? There is a field called length. This will tell you that what is the length of the frame. So whenever you are sending total altogether 110 characters I am sending, please observe. 110 bytes I am sending. Because all data are being transmitted in the physical layer in the form of bits only. All are being merged together and transmitted. But whenever the receiver side data link layer receives it, then it understands that by seeing a field called length, it can able to understand that how to cut the frame. So it cut the first 10 bytes into one frame, and rest it is going to consider that another frame, because I know the length of the frame. Here length of the frame is 100 bytes and here length of the frame is 10 bytes. So how easy at the receiver side, that receiver side means data link layer. Please understand, my dear friends, not a user. How easy to the data link layer at the receiver to be able to identify the boundary of the frame by taking a length. Here I am not adding any kind of a padding. Please observe carefully. I am not adding any kind of extra stuff because a frame consists of different kinds of data sets. But I am also providing a concept called what? Boundaries to the frame just by taking a special field which you maintain in the header called length. So by maintaining a length field, the receiver side data link layer can able to cut it exactly by seeing the length. But there is another big problem in this. What is the problem in this? If length is corrupted, please observe. If length is corrupted, then it is not possible to identify the boundary of the frame. Please observe, my dear friends, that is one of the big drawbacks. What is that? If length field is corrupted, then unable to identify boundary of the frame. So this is one of the drawbacks. So one of the mechanism towards the length implementation in the variable length framing is character count, that we will learn. And now the second alternative method in order to avoid your padding concept is end delimiter. End delimiter is another way, along with like length is also one kind of variable length framing, and end delimiter is also one of the variable length framing technique. So here we are going to add end delimiter. So according to the delimiter, we understand that after end delimiter, next is our next frame. So once the receiver receives a frame up to the end delimiter, continuously it will be read and it stops at the end delimiter. It understands that that is the separation between your previous frame and the next frame. So the frame up to end delimiter, it performs reading and indicates that that is your end of the frame only. Therefore, my dear friends, you will see that start of frame delimiter SFD and end of frame delimiter EFD. So every frame is associated with two important fields. Start of the frame and end of the frame is nothing but start of frame delimiter, end of the frame delimiter. In middle you are having your data and other fields. So here there are two examples. I am saying frame 1 and frame 2. So initially it is a start of the frame delimiter and your payload is there in middle and end of the delimiter is here. And when you start the next frame, again same sequence we will follow. What is that? Start of the frame delimiter and the data, end of the frame delimiter. So this is how simple using an end delimiter concept to be able to separate your frames at the data link layer of the receiver side. So this is how you can able to differentiate a length from end delimiter concept. So what is the main drawback? You need to follow extra start delimiter and end delimiter. That is a pattern. You need to first understand what is the pattern you want to follow. That is an agreement between your sender data link layer and the receiver data link layer, that what is your delimiter pattern. So you need to first to decide your delimiter pattern. If a pattern matches with the data, this is so dangerous. If your data consists of the same pattern, then you are unable to identify the boundary. What is the disadvantage? What is the example you want to ask me? See that? I am saying that your delimiter is a flag. When you say that your delimiter is a flag, and I am also saying that my data is ABCD and 1, 2, 3. So what I am doing, I am trying to cut and send the frames, because the frame can consist of more number of characters. Don't worry, because we are doing a random size or variable length framing. I am adding some particular data here. So initially there is a requirement of your flag. Why there is a requirement of a flag, my dear friend? Because your frame is identified by start of the delimiter and your frame is end with the end of the delimiter. So this is a completely one frame. And the next frame, again you need to identify, this is completely is a sender side responsibility. So again he is saying start of the delimiter, and again he is saying that end of the delimiter. What is your delimiter? Your delimiter is a flag here. Your delimiter is a flag. So here also there is a flag, and the rest can consist of D1, 2, 3. You observe here, this frame consists of 3 characters and this frame consists of 4 characters. It is a 4 bytes and it is a 3 bytes. So no problem whatsoever, this is allowed, especially in variable length framing. But what is our disadvantage? I will show you the disadvantage. Observe. Your delimiter is a flag. Now your data is ABC flag 1, 2. Now you observe, I am constructing the frames. Frame 1 starting with your flag, and ending also is with the flag. This is the end of the delimiter. This is the start of the delimiter, and ABC is your data. And you observe carefully, if I dump this flag also here, this is completely your data. ABC flag is our data, and the rest of the frame is, again there is a requirement of what? Again there is a requirement of the start of the frame, nothing but a flag, and end of the frame, that is nothing but a flag, and middle rest of the data, that is nothing but 1 and 2, it is a data here. Now you tell me friends, if receiver receives this is at sender side. If receiver receives the frame 1, how are you able to identify boundary of the frame? You will see that start of the flag, and you will see that A is the data. Let me write in a different font color. I will say that A is the data, and B is also data, and C is also data. As soon as he find the flag, you will understand that this is your start of the delimiter and this is your end of the delimiter. Therefore, he will cut the frame up to that. So he will understand that ABC is your data. But what we are missing, my dear friends? We are missing a flag which is embedded in your first frame. We are missing the flag which is embedded in your first frame as it is a data. So we lost data of your flag. This is another big problem. That's why to avoid these problems, there are some methodologies are there, like bit stuffing and byte stuffing. Let us see them. So end delimiter methods. End delimiter methods are bit oriented and byte oriented. Bit oriented is a flag byte stuffing or character stuffing. byte oriented. Bit oriented means a bit stuffing, and this is a count. So I can able to say that the length, it is the following, very similar to length. Okay, my dear friends, so let us go back. There are two kinds of framing methods, especially in variable length. One is called a length field. The other one is called end delimiter concept. So I want to consider character count into length side, and remaining all I want to consider into end delimiter only. First of all, let us see what is a character count. The character count is saying that how many number of characters are there in your frame. That's the meaning of length. How many number of characters are there in your frame? You need to maintain a special character called count that will tell you that number of available characters in your frame. Therefore, by seeing the count field at the receiver side, receiver can able to identify the boundary of the frame just by counting how many characters you want to cut it. So apart from your data, I need to maintain a special field called count. By seeing the count field, because your data consists a set of group characters, I am able to cut them according to your count field only. So it is based on characters. That's why I'm sending the data in the form of characters only. Every one character is equal to 1 byte. So character count I am taking. It uses a special field in the header to specify the number of characters are available in that frame, including the count field. Including count field, how many characters are there. So when the data link layer at the destination sees the character count, it understands that how many number of characters to follow, and hence where is the end of the frame. So receiver is going to follow up to that particular point. So this is one of the example of your Tannenbaum. We will also see our examples. So 5 is your character count. So whenever you send this data to the receiver, please understand, whenever you send this data to the receiver, he will see that exactly 5 characters into one shot. So this is a 1 and 2 and 3 and 4 and 5. So there is a boundary. This is your frame 1. And again I am saying that count is a 5. So including count 1, 2, 3, 4, 5. This is your frame 2. See the sender how he is using a very beautiful technique. Next he is saying that count is 8. 8 characters I need to expand it. So 1, 2, 3, 4, 5, 6, 7, 8. Next the count field is enabled with 8. So 8 characters we want. So 1, 2, 3, 4, 5, 6, 7, 8. So this is how. This consists of 8 characters this frame. This consists of 8 characters this frame. This consists of 5 characters this frame. This consists of 5 characters this frame. Yes, this is eligible as you are using a variable length mapping. But what is the problem here? I already told you, if length is a corrupted, if character count is a corrupted, then you are unable to identify boundary of the frame. For example, you see, the receiver received a stream of data like this. This is what is arrived at the receiver side data link layer. Data link layer of your receiver. Observe. Now, first he got 5. 5 is nothing but character count only. He is trying to read up to 5 characters as a one frame. So character 1 already character count, character 2, 3, 4, 5. It's a fantastic find. Then after that, the next field is automatically count field. I got 7. 7 means I am looking only 7 characters only. So 1 and 2 and 3 and 4 and 5, 6, 7. And next character is a character count automatically. After ending that, that is only character count. Your character count is only 1. 1 means your count character is only 1. So remaining, I am unable to identify boundary of the frame. That's why, my dear friends, actually the frame 2 consists, observe carefully, the frame 2 consists here 5. The frame 2 consists here 5. 5 means 5 characters sender has sent, which consists of n minus 1 data characters only. 1 is a character count. But here, instead of 5, it is just corrupted and appeared as a 7. When it appeared as a 7, that's it. You lost the boundary of your frame. So you are looking at 7 characters, but sender has sent in that frame only 5 characters. Therefore, you are unable to identify the boundary because you understand. Please clearly observe. This 8 is actually your character count. But I am considering that 8 as your data. Please observe. Very, very big blunder this is. That 8 is actually character count, which is saying that is your, which is used to say that the length of the boundary of the frame. But here, due to this error, due to this corruption, I am considered that 8 is also data, but that is a wrong frame. Apart from that wrong frame, next frame boundary I am unable to identify. It's a big problem, especially in character count. So there is one application which is following a character count. What is that? DECnet. So DECnet is one of your character count example. What is the drawback? Receiver losses synchronization when bits are not received in the order. So 1 point. And if the bits in the count becomes corrupted, then receiver thinks that the frame contains either less characters or more characters. Therefore, unable to identify boundary of the frame properly. Example is DEC and ET. So the second variety, because of the drawback, whenever you are following a character count which is following a length type, there is a concept called byte stuffing. So what the byte stuffing is saying? Every frame is identified by pattern because we are using a delimiter here. Start of the delimiter and end of the delimiter we are following. Second methodology I am following. Please look at the flow diagram which I gave you. This is the flow diagram. One we already discussed based on length, that is a character count. What are the two problems? If count got corrupted, we are unable to identify boundary of the frame, and count is also considered as the data in the previous frame. That's why we are using the concept of what? A delimiter system. Delimiter is nothing but bit stuffing and byte stuffing are the two techniques which are following start of the delimiter and end of the delimiter. So every frame is going to identify with start of the delimiter, nothing but a flag. If I am taking that my pattern is a flag, you can take any kind of pattern, but I am taking a flag. And end of the delimiter is also supposed to be same pattern only, flag. So every frame is supposed to have start of the frame, end of the frame, and in middle you can have a payload. There is no character count, simply we are trying to identify start of the delimiter and end of the delimiter pattern concept. So we are having DLE STX, data link escape character, as a start of text, and DLE ETX, which is nothing but data link escape end of text, end of the delimiter and the start of the delimiter. Every frame is having a starting and ending flag byte sequence. So what is the problem? I already told you. If data contains a delimiter sequence, then you are unable to see that the flag, if at all it consists in the data, then you see that up to that only you are going to consider as a frame boundary. Therefore, you are unable to identify the frame boundary there. This is one of the assumption in this. If the flag delimiter is appeared in the data, then what are you going to do? That problem you can able to avoid by using the concept of a stuffing. That is the meaning of byte stuffing. If at all your data do not consist any kind of a flag pattern, then there is no stuffing. For example, sender data link layer is sending data A, B, C, and your delimiter is I am following flag. Your data do not consist any kind of a delimiter sequence. I can happily transmit my data using a what? Your start of the frame, that is nothing but a flag, and your end of the frame, that is nothing but a flag, and there is a direct data I can able to write as ABC. I need not stuff any kind of data. Here your answer is 0 character stuff. 0 character stuff. Because because your delimiter sequence is not occurred in data sequence, is not occurred in data sequence. That's why there is no requirement of what? Stuffing. When are you going to do the stuffing? I already shown you. For example, your delimiter, if you consider, is a flag. Now sender data is ABC flag 1, 2. Now it's a big problem. Why big problem? Now sender data link layer, it is attaching your start of the delimiter and end of the delimiter. Your start of the delimiter is observed. Your start of the delimiter is flag and your end of the delimiter is a flag. Now you observe carefully, I am posting the data middle. What is that? So I am sending now ABC and flag and 1, 2. So no stuffing here. Simply I am releasing my data. No stuffing. And what is going to happen? Whenever receiver side DLL receives this, let us change the font color. He received a flag here and the ending flag is also there, and we are having a data ABC flag. And where is the boundary of the frame? You can easily say, where is the boundary of the frame? This is your start of the delimiter, this is your data, this is your data, this is your data, this is your end of the delimiter, because your pattern is end with the same pattern. Therefore, we will consider this flag as your end of the delimiter, not as a data, but here the flag is your data. That's why whenever you see this kind of a situation, there is a requirement of a stuffing. There is a requirement of stuffing an extra character preceded to that. Therefore, the receiver can understand that that is the data, not the end of the delimiter. And what is the stuffing character? That is up to you. Naturally, we are going to use, by escaping that, we are going to use a escape character. Data link escape, DLE. We are trying to use DLE. What is the full form of DLE? Data link escape character. It is nothing but link escape or frame escaping. So this is your stuffed character. DLE is your stuffed character. Now what is the solution? I will show you. Look at carefully. As usually, sender is sending. Same example I am taking. Flag is there. And your data is ABC and a flag and 1, 2 and a flag. We are considering, sender is considered that this is your data. This is your data. And this one is your end of the delimiter. So start of the delimiter, end of the delimiter, and this is your data. So he is observing that your data is matched with your flag pattern. That means delimiter pattern. So receiver, to avoid this ambiguity, at the receiver side, what the sender is going to do is doing what? Byte stuffing. This is also called as character stuffing. This is also called as a character stuffing. So what I am doing? So earlier flag and ABC, and this is your data flag 1 and 2, and this is your flag. As you understand that data is coming and which is matched with your delimiter sequence, I'm going to add one extra character, that is a stuffed character called escape DLE. This is by default. You can change whichever you want, as like your DLE you can change. You can also change your delimiter pattern also. But provided that your delimiter pattern must not come into the data sequence. If it comes, you need to stuff it. So what is the advantage by doing this? What is the disadvantage by doing this? Disadvantage is extra overhead, because I am sending one character is nothing but 8 bytes. So therefore, what happened? When this is arrived to the receiver start understand this is your start of the delimiter. A is the data, B is the data, C is the data. Escape is followed by flag. Please understand. Escape is followed by your delimiter sequence. Then we will understand that escape is a stuffed character, flag is your data, and 1 is your data, 2 is your data, and there is no escape to your delimiter sequence. Hence, I can confirm that this is your end of the delimiter. So whenever escape is preceded by your delimiter sequence, we will understand that the escape is a stuffed character. You can remove it. So after removing, please understand that these tick marks are character data only. But so advantage is superb. You can able to identify the boundary of the frame excellent, because we are separation this kind of problem using escape character. But what is the drawback? Overhead. So how many characters I am sending? Actually, I want to send 1, 2, 3, 4, 5, 6. 6 characters I want to send. I am sending 7 because this is extra to us. So efficiency is also going to be slightly changed. If there is another sequence is there, let us say your stuffed character, we are assumption that there may be a chance of your data pattern may consist of your end delimiter pattern. So I am saying that escape character, and your end of the delimiter is start of the delimiter, end of the delimiter is a flag, and the sender data is AB, escape, and flag. Observe carefully. So AB, escape, flag. Followed by some 1 and 2. Now what is going to happen? Sender is constructing as usually. Let us say red for your starting and ending for better understanding. And middle you are having your data. A is the data, B is the data, escape is also data. Please understand. Escape is also your data, and flag is also your data, and 1 and 2 is your data. So before you transmit this data to the receiver, sender has to do some additional responsibility. What is that? You need to check that your data sequence is matched with your delimiter sequence. Yes, it's matched. Therefore, what I am going to do, I will stuff escape character here. This is a stuffing. So when you send this data to the receiver, then what is going to happen? Observe carefully. So flag, AB, escape, and escape flag, and 1, 2 flag. So what is going to happen? Please see. This is the big problem. If I add here one more flag, so you can better understand. If I am taking one more flag here as your data, then 1, 2, then what is going to happen? You need to stuff. Need to stuff double. As many delimiter patterns occurred in your data sequence, those many you need to stuff it. So A is the data, B is the data, and escape, and next to escape, and next to flag, and next to escape, and next to your flag. So for this flag, I am stuffing, and again there is a requirement of escape DLE. DLE is nothing but data link escape. This is the flag 1 2, finally your flag. So this has come to the receiver. Now you observe carefully. You will understand that this is the start, this is your end. Now your data I am considering. A is the data straight, B is the data straight, and what is this escape? So as you are saying escape character and double escape is there. So we are in dilemma whether to consider this escape as a stuffed character or this escape is a data character. That's what we are going to do. So to avoid this ambiguity, whether to consider this escape as a data or to consider this is as a stuffed character. So therefore we are in dilemma because there are two escape characters are. That's why to avoid this ambiguity, what the sender side responsibility, one more responsibility is there. What is that? So two important assumptions. One important assumption is whenever you see that your delimiter sequence is appeared in the data sequence, then you need to stuff escape character. And one more assumption is that if your DLE character is also available in your data, so this is available in your data and this is available in your data. Therefore, for DLE also you need to precede one more data link escape so that receiver do not have any kind of ambiguity. So finally, I am writing A, B, and blue color is a data escape and your flag and your flag 1, 2. They are all your data. Now I am adding stuffing. So because this data link escape sequence character is occurred in your data, so I need to stuff it extra one more. This is a stuff, and whenever there is a flag appeared, there is a requirement of a stuff, and whenever there is a flag appeared, there is a requirement of a stuff. So I stuffed three characters. One is for occurrence of your data link escape character, and two are for occurrence of your delimiter sequence character. So whenever receiver receives this complete frame, so he understand that this is your start of delimiter, and you will see that data part and stuffed characters part. So blue color one, A and B is the data, escape is the data, and flag is the data, and flag is the data, 1 and 2 is the data, and your escape sequence is also appeared, escape sequence is also appeared, data link escape sequence is also appeared. You will understand like this. Whenever you see the two escape characters, this is the stuffed. Whenever you see that escape followed by your delimiter sequence, this is stuff. Whenever you see that your extra character preceded by your delimiter sequence, that means DLE character before your delimiter sequence, I can consider this is your stuffed character. So he will consider that the round one are your data, remaining is eliminated. No problem whatsoever in order to identify boundary of the frame. Pakka. But only one problem. What is the problem? The drawback is overhead. Disadvantage is overhead. According to previous example, I stuffed three characters out of, please see, out of 1, 2, 3, 4, 5, 6, 7. Out of 7 characters, I stuffed 3 characters extra. So 3 is your overhead, and your link efficiency is nothing but useful divided by total. Useful is a 7 character, total is a 10 characters. This is your finally your efficiency is a 10 by 10. So let me show you the theoretical points. So whenever your flag sequence appear in data sequence, or whenever your DLE sequence is appeared in a data sequence, you need to stuff one more character according to like this. So flag, header and trailer and payload. This is your frame format. Please understand, header and trailer is mandatory. Trailer consists of error detection codes. Header consists of source address, destination address, and others. And payload is nothing but your data only. Now you see, so A, B are your data, and flag is there your data also. Therefore, what is going to happen? Your flag is appeared as your data, so I need to raise a one stuff. This is your stuffed character. So receiver will eliminate. And next original characters are A and B. This time I am sending your delimiter sequence only. Your delimiter sequence is in the first example. Now escape is your stuffed character, which is nothing but DLE character, data link escape character, which is nothing but your stuffed character. So if your stuffed character is there in your frame, what you need to do? You need to raise ambiguity so that according to the ambiguity will understand that one I need to keep, one I need to eliminate. That's the meaning of ambiguity elimination. So to this escape, I am adding a one more stuff. So escape and flag is there. One ambiguity for your escape, that means DLE character. One ambiguity I want to add for your delimiter sequence. So this is your stuffed character, this is your stuffed character. Escape, escape. So one stuffed character and one stuffed character. So this is how you can able to close flag byte stuffing. There is no problem whatsoever, especially in identifying boundary of the frame. Very easy. Only one problem, power head is more. So already we shown you this kind of examples. So flag and flag. There is no concept of extra here. No stuffing. Because your data is not consist of escape data character as well as end of the delimiter character. And this is if you observe. So I am using a flag. And this is your flag sequence if I am saying. That is your flag sequence I am saying. So you need to use the 8 bits because one character is equal to 8 bytes. Therefore what happened? Start of the delimiter, end of the delimiter, ABC and this flag sequence followed by your K and P. So what happened here? This flag and this flag is matched. So you will understand that ABC is only the data. This is wrongly arrived. That's why there is a requirement of a stuffing. So I am doing the stuffing for the same example. So this is your delimiter sequence. ABC flag KP is your data. So flag and flag ABC and escape is required followed by your original character. So the receiver is going to accept like this. Whenever your DLE character is preceded by your end of the delimiter sequence or your DLE character is appeared in your data sequence, I am maintaining ambiguity. So I can cut one extra character, escape character. So what is the problem? The problem with your byte stuffing is overhead. This is a big problem. So this problem can be eliminated. Instead of stuffing 8 bits, observe carefully. Instead of stuffing 8 bits, instead of stuffing 8 bits, 8 bit is nothing but one character only, nothing but one byte. I am stuffing, we will stuff only one bit to separate. Please understand carefully. To separate what? Data sequence from delimiter sequence. Data sequence from delimiter sequence. So earlier also we separated. Please observe. Earlier also I separated. Earlier also we separated, but we are separating what? We are separating using 8 bits, but here I am using only 1 bit only. Data sequence from delimiter sequence. But I will not use 8 bits, simply I will use 1 bit only. See, lot of savings. What are the savings? Instead of injecting 8 bits as a 1 character, I am inserting only 1 bit only. That's why it is based on bit stuffing. Very, very important example in the GATE examination. Bit stuffing is nothing but same. Frame begins and end with a flag delimiter only. Whenever delimiter sequence is matched with your data sequence, I don't inject 8 bits. I will inject only 1 bit to separate your data stream. That is opposite bit I will do. For example, your default sequence is 0610, 8 bits altogether there. They are 8 bits together. So whenever this sequence occurs in your data sequence, I'm not going to implement all the 8 bits as extra ambiguity. What I'm doing, simply I will stuff a 0 after 5 consecutive ones. So receiver side, the 0 bit is being removed at the receiver side. And why to stuff only 0? Because opposite character will tell you that that is the separation. That's why if you use once again 1, it is not going to be separated. And why to use only 0 after 5 consecutive ones? I will show you. Look at. Please observe this example carefully. My data is, now I am going to write in the form of bits because I am following bit stuffing. 10 110 111110 and 0. And now my pattern 0 11110. We don't mind about left 0 and right 0. Our intention to separate here only. What is the meaning? So your data is not consist of this sequence. 6 ones sequence it do not have. So 1 and double 1 and 5 ones. There is an important point here. What is that? So whenever you see that 5 consecutive ones, there is a requirement of a stuff. Why? I will show you. The stuff can be, please understand, the stuff can be here, the stuff can be here, the stuff can be here, our stuff can be here, our stuff can be here. Stuff must not be before 1 and must not be, that means what? Before 6 ones or after 6 ones. After 6 ones there is no use. Before 6 ones also no use. That's why you can separate in between by stuffing 0 bits. If I am stuffing here, what will happen? For example, let us see. My data is 10 110 110. Now I am saying that stuffing after every 1 bit. That's the meaning of this. What is your pattern? Your pattern is 0 1 2 3 4 5 6 0. This is your delimiter pattern. What I am doing? Stuffing 0 after every 1. After every 1 bit. Therefore, you see that I am separating the sequence by separating like this. So if I am taking a 1, 2, 3, 4, 5, 6 here, what will happen? The frame is look like 1 0. The frame is looks like 0 1 2 3 4 5 6 0 0 1 2 3 4 5 6 0. This is end of the delimiter, start of the delimiter. Similar to byte stuffing only. This is the one border. Now let us see the data. Before transmitting sender, what the sender assumption, let us see. So 1 0 no problem and double 1. Whenever you see double 1, start stuffing 0 after every 1 bit. Therefore what happened? I need to stuff here 1 0. So I need to stuff here 1 0 as I am saying that. Please observe carefully as I am saying that. After every 1 there is a requirement of 0. That's what we are guessing. Right? Because I am trying to stuff here only. So therefore what happened? After every 1 you need to inject what? 0. And remaining your data. 0 double 1 0. Now here you need to stop 0. Here you need to stop 0. Again 6 ones. 6 ones means you need to add. See how it is separating this sequence from your delimiter sequence. So 1, 2, 3, 4, 5, 6. Because your delimiter sequence is matched with your data sequence 6 ones and 6 ones. So I may see that whenever receiver receives this, I see that 6 ones and 6 ones pattern is matched. Therefore, this may be end of your boundary, but that is the wrong approach. What I am doing, I am stuffing, I am separating it. 0 and 0, 0 here, 0 and 0. So this is how, see now, your data sequence is not matched with your delimiter sequence. This is how you can separate your delimiter sequence from data sequence by stuffing after every one bit. But if I am doing after 2 bits, 0 somewhat reduced, after 3 bits, 0 somewhat reduced. That's why what is our intention? The probability to reduce the number of zeros, better you stuff after n minus 1 bits. So end of the bit before you stuff, then it is also going to separate. So what is our example, my dear friends? Your data is 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 0 and 1. And your delimiter sequence 1, 1, 1, 1, 1, 1. So if I add 0 after first one, more zeros will be stuffed. 2 bits after 0, somewhat better. 3 bits after 0, somewhat better. 4 bits after 0, somewhat better. 5 bits after 0, this is very, very beneficial. Because I cannot keep after 6 bits 0. You do the 6 bit 0, again it is going to map with your delimiter sequence only. That's why, what is our assumption? This is the best probability. What is our best probability? After 5 consecutive ones. After 5 consecutive ones, stuff a 0. What is the advantage? Probability number of 0 bits are reduced. 0 are nothing but stuffed bits are reduced. Therefore, my dear friends, see the beauty of this model. I am stuffing last bit before only. Therefore, the sender before transmitting to the receiver, 6 ones is your delimiter sequence. So he will try to see that 6 ones starting, 6 ones ending, and let us see your data. What is your data? 0 is your data, 1, 2, 3, 4, no problem. After 5 consecutive ones only, no stuffing, and 0. And now you see 1, 2, 3, 4, 5. Whenever you see that 5 ones, we want to separate this. Therefore, 0, and next your data is 0, 1. So only one stuff. So this is how you can able to reduce number of stuffed bits. If you use 1 bit after 0, 2 bits after 0, 3 bits after 0, 4 bits after 0, the probability of raising of your zeros are more than this. That's why better you stuff always after last bit. Before last bit we are trying to stuff. This is the concept. This is the advantage. One more example I will show you before closing this. So your delimiter is 1, 1, 1, 1. What is the meaning? What is the best probability for the stuffing of 0? You know, if I insert here more zeros, after 2 ones more zeros, after 3 ones somewhat better, after 4 ones is invalid. Because even you keep 0, no use, it is matching over there. Therefore, the best probability is this only. Best probability. So what I am doing? Sender data is 10111011101111 and 0111. So what is your sender side frame after stuffing? After stuffing, this is completely responsibility by sender only. After stuffing, let me write a red font 1, 2, 3, 4 and 1, 2, 3, 4 is your start of the delimiter, end of the delimiter. Instead of stuffing 8 bits like your byte stuffing, I'm stuffing only one bit. Let me say, what is your probability? After 3 ones, I want to separate using 0. So 1 0 no problem, double 1 0 no problem, but triple 1 0 whenever you write triple 1, our assumption is that we are separation because we have written a coding like that such after every 3 ones I am going to stuff 0. It is a mandatory. Don't think that there are no 4 ones. How are you going to separate? As we see that, what are we assuming? After 3 consecutive ones, after 3 consecutive 1 bits, there is a need of 0 bit. According to that, it is going from starting to ending by stuffing. So this is done. Then 1, 2, 3. So 1, 2, 3. Again, there is a requirement of stuffed bit. Then after that, double 1, no problem. And 0, no problem. After that, triple 1. So whenever you see the triple 1, our rule is that stuffed bit. So this is how you see that the stuffed bits are like this. So how many stuffed bits I did? 3 stuffed bits. So whenever receiver receives this frame according to like this, I also will know what is that. Whenever there are 4 ones, the best probability the sender is following that after 3 ones, 0 might be stuffed. So I am also following in the same story. He will receive this data as 1 0 double 1 0 1 1 1 0 and 1 1 1 0 and 1 1 0 and 1 1 1 0. So he is trying to eliminate them. What is the rule of elimination? After every 3 consecutive ones, eliminate 0. This and this and this. So you got your original data. What is the advantage? The advantage is superb. Number of extra stuffed bits are 0. So according to this example, we are separating after every 5 ones. So in this example, we are taking a delimiter as, you guess, 6 ones. Because we are using after 5 ones, 0 means it is nothing but your delimiter sequence is 5 plus 1, 6 ones. These are the examples, you can go through it. If any pattern matches with the end delimiter, then break the pattern by stuffing a 1. So instead of 1 byte, you are just splitting only 1 bit, therefore overhead is less. So your flag pattern same like this only. So whenever your flag pattern is appear, I am separating just by doing a what? 1 stuffed bit. So why to use after last bit before I am doing a split? Stuffing means if you are doing after 1 bit or after 2 bits, after 3 bits, number of zeros are being increased. That's what I am going to do. Last before bit I am going to do what? Stuffing. So that number of stuffed bits are going to be reduced. So this is one of your example. Delimiter sequence is a 4 ones. 4 ones means after 3 every consecutive ones we are inserting 0. So here you will get a 0. 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 So therefore you see that after every 3 ones we are trying to use a what? This is your start of the delimiter. This is your end of the delimiter. So who is using bit stuffing, my dear friends? Bit stuffing is followed by high level data link communication. Right now we are using. And byte stuff we is using SDLC. Character count we is byte stuffing we is using BiSync protocol also is following. And character stuffing is followed by DECNET. That's it, my dear friends. This is how the framing construction methods. So thank you for your valuable time, and I am on behalf of Unacademy. So assurance that you can able to get a good marks whatever subjects the educators of Unacademy is teaching. You're going to get high marks. Immediately subscribe into Unacademy because the prices are going to be increased. So I think so by tomorrow or day after tomorrow the prices are going to be increased. Immediately take the admission. Why to pay extra? Please keep it that one in mind. Why to pay extra? Use my referral code today or tomorrow. Immediately join in Unacademy. Therefore, if you use my referral code, you are going to get a maximized discount because discounts are also may be stopped. That's it, my dear friends. Thank you very much for your support. Please do like. Any doubts you are having, please mail to me. Thank you very much. We'll meet in the tomorrow session with other responsibility of data link layer. We have seen data link layer frame responsibility. Tomorrow we will see error detection. That is a trailer case we will look at. Thank you very much.